In this section, I'm going to be talking about confidence and prediction intervals for simple linear regression models. Now, there's a lot of math in here, but I'm going to simplify as much as I can. First thing I'm going to be talking about is the simple linear regression confidence interval for the mean. So if you notice in the graph on the left, a linear regression is calculated to fit the sample data points. So if you have a scatter plot, sample data points, regression line is calculated to fit the sample data points. The confidence interval consists of the space between the two curves, which in this case is a dotted line. So if you see there's a dotted line here, there's another dotted line here, right in the middle, that is your fitted line, which falls in between the confidence interval for the mean. Now the next part is a simple linear regression prediction interval for an individual response. So again, here's your formula, and if you notice you have S of y, that is the residual standard error. Now a prediction interval for an individual response quantifies uncertainty when the fitted value is used to predict y for a fixed value of x. A little heavy here, and with examples, this will make a lot more sense. But just as a summary, this interval is wider than the corresponding confidence interval for the mean. So over here, if you have the confidence interval for the mean, the prediction interval for an individual response is a lot wider. And again, with an example that I'll go through, you'll see that visually and understand it a lot better. So let's begin. So I'm going to use the same data set that I've used in the past. I'm going to copy and paste some code. And if you recall, this is my heart.csv, which was used in the previous lectures. And I'm going to go ahead and paste the link. Actually, I'm going to try to paste it over here. And if you remember, this is the heart attack analysis and prediction data set. So going back to my example, now if I run this, as you have grown very accustomed to, I'm going to read my CSV file and then load it into my data frame called health2. Excellent. And if you recall from my previous lecture, I'm going to be focusing on two variables, talach and age. And talach in this case is the maximum heart rate. So first thing I would like to do is find the correlation between these two variables. So I type the following, I use my data frame and then look at my variable for the maximum heart rate and then age and find the associated correlation. And right off the bat, you can see here it's negative 0.39. That is the relationship. And if you recall, when we talked about this relationship, we were saying that this is a weak to moderate downhill negative linear relationship. The next part, I would like to create a model for my ordinary least squares regression. So I'm going to try to create this model so that it would generate my regression results for the ordinary least square regression results. And we've done this in the past. Excellent. Now, I'm going to show you a trick that we've used in the past where to find a predictive value for a given x, first the data frame should be created and then the predict method should be used. So I'm going to do a slight variation here. I'm going to import numpy as np. Type x0 equals pd dot data frame np dot array. In this case, columns equals h. last part. All right, let's go do a quick check here. All right, excellent. So with a predictor value for age 40, for a 40-year-old, the model predicts the maximum heart rate to be 164. Now keep in mind to find the confidence and prediction intervals for a given x. Now this is new. We use the get prediction method. Now, again, we used the predict method in the past. This is a little different. So now, if we type intervals equals model dot get prediction x0, and the next part, intervals dot summary underscore frame, aha, we get an amazing output. The following output shows the mean, the standard error, the mean CI upper, confidence interval upper, mean CI lower, mean confidence interval lower. So again, those are the lower and upper bounds for the confidence interval. And as you can see, the last two columns, obs CI lower, obs CI upper. Now those are the lower and upper bounds for the prediction interval, respectively. That is awesome. That's exactly what we were looking for. That's all what we need to be able to figure out our simple linear regression confidence interval for the mean and the simple linear regression prediction interval for an individual response. In this case, our response is going to be our maximum heart rate for a value of x. In this case, the x value is our age. That's the variable. Now the fun begins. So what I'm going to go ahead and do is copy and paste some code to find the confidence and prediction intervals for a given x that's in a range to get the associated summary frame that contains the lower and upper bounds for the confidence interval and the lower and upper bounds for the prediction interval. So over here, I pasted some code. And right off the bat, you can see that I am creating a range of values for my x, in this case from 29 years of age to 82. I'm going to be creating a data frame for my confidence intervals that contains the summary frame, which as you see right in the cell above, this is my summary frame, but in this case is going to range for the values from 29 to 82. And here we go. All right. So as you can see here, because I use head, I'm going to only be showing the first 5 records. But as you can see, for my x values, I was able to determine my mean, confidence interval, the lower and upper bounds, and I was able to determine the prediction interval, the lower and upper bounds, which is amazing. Now let's try to plot. So what I'm gonna go ahead and do is copy and paste some code. And this is code that we've used in the past. If you remember this is a scatter plot for maximum heart rate versus age. And we have a regression line and then any value, and it's our threshold where it seems like as a maximum heart rate, when it's above that threshold, there is a higher chance of an individual having a heart attack. Just as a disclaimer, I'm not a doctor. This is just from the data set. We're just playing with the data here. But now I want to alter this code slightly to plot my lower and upper bounds for the confidence interval and my lower and upper bounds for the prediction interval. Crossing fingers, this is now going to line up to the figure that I showed at the beginning of this lecture over here. Hopefully we're going to get something very similar to this when it comes to the confidence interval for the mean and the prediction interval for an individual response. All right. So I'm going to copy and paste some code. run it. And here we go. Amazing. This is exactly what we're looking for. Now, if you remember the line, the black line over here, that's your fitted line, that's your regression line. The green line and the red line over here, just pointing to them right now, those are your lower and upper bounds for the confidence interval. And then you have your blue and your pink lines. Those are the lower and upper bounds for the prediction interval. Now, if you notice over here, for the confidence interval for the mean, that interval is narrower than the corresponding prediction interval for an individual response, but it's 95% confidence interval for the mean. Now, on the flip side of the argument, the 95% prediction interval for an individual response, now that interval is wider than the corresponding confidence interval for the mean, which is amazing. So we were able to recreate the figure for our data set that we're looking at in the previous lectures. Amazing. This concludes our section on confidence and prediction intervals for simple linear regression.